Okay, so I'm looking at the chi-square test for association in the last lab and want to point out a couple things. The idea of a chi-square test for association or independence among variables is, for example, this data here. We have folks that were inoculated, folks that were not inoculated, okay? We want to see, is there a relationship? It's categorical variables, like a yes or a no, and they either lived or died. So we could make a scatter plot of this. But if the variables are unrelated, then we'd expect, let's say, 238 out of 244, right? That proportion that lived, that were inoculated, that shouldn't be too different from 5136 out of 5980, right? That would be the proportion of folks who were not inoculated and lived. Those proportions should be about the same, and then that would indicate that there's really no association between mortality and inoculation. So what this little template does for us here is it calculates a chi-squared statistic. And what you have to understand about chi-squared is it's a skewed right distribution. It's completely skewed right. So it has this long tail to the right. So the only way we get a significant chi-squared value is if we get a large value, right? If there's no association between these two, right, then we'd expect this ratio to be 210 to 33, and this one to be 5163 to 816. These ratios should be about the same, okay? If they deviate so far from that, then the chi-squared statistic gets bigger. We just find the deviations. That's how we calculate chi-squared. It's a summation of those differences, or proportionally different. So we have our actual values and our expected values, and the expected is, again, a null hypothesis that the two variables aren't related. If these differ by a lot, then this number gets a lot bigger, okay? In order to have a significant result, the number we would need would just be 3.84. We have such a large sample that we don't need that big of a number difference for a significant result. So the way we would interpret this is that the chi-squared value of 27.005 is so much larger than the critical value, 3.84, right? A chi-squared value of 3.84 is going to happen less than 5% of the time if the two variables are unrelated. So what we would do is we would conclude that the variables must be related. We reject that null hypothesis and conclude that they are related. So one of the things the lab asks you to do is go back and revisit lab 1, right? Here's lab 1. In particular, the pivot table that we had, right? Remember, was there a relationship between smoking and gender? That's what this pivot table sort of lays out for us, right? Females smoke the Smoke 100 question, right? Or even better to look at is this number down here, right? This is a little bit more telling, right? 30% of women said no, they don't smoke, right? Or not 30%, but it's 30% of the total. But of this 52% of the sample were women, 48% roughly were men. So the breakdown here was 30 to 22. This one was 22 to 25. So you can see right away, just percentage-wise, there's a higher proportion of the males, proportionally, or lower rather, that don't. Higher that do, 25 do to 22, right? Whereas with the females, these are kind of reversed. So just with an eyeball test, it almost seems like the variables are related, right? Like that men are more likely to say yes to the Smoke 100 question than the women would be. Well, we could use chi-squared to test that. That's what my instincts say by looking at those numbers, but I can't tell just by looking at them if they're statistically significant. So what we can do with that other template, I can just take these totals that I have, and you want totals, okay? Chi-squared, sorry, just these guys here, just the 4. Chi-squared does not work with decimal counts, okay? Your expected counts, let me go back to that chi-squared table. I'm going to copy this. I'm going to hit Control-C while it's highlighted. Now I'm going back to our lab for this week, okay? But notice you can get decimals for your expected counts, but you can't have decimals over here. That's not going to make any sense because it means you observed those data or you gathered it and got decimals. They have to be actual counts. So I'm taking those 4 blocks that I just copied and I'm going to hit Control-V here and paste them, and notice everything changed, right? Look at my expected counts, how they changed, right? So this doesn't read this way now, but again, this is Smoke 100 no, this is Smoke 100 yes, this is women and men. To get the chi-squared result, it really doesn't matter. I can just I can apply that to the application. So I look and see, here's the new chi-squared critical value, 3.84, and now my chi-squared statistic. So it's kind of just like we thought. It looked like the two variables were related, that there does seem to be a pretty significant interaction between gender and how they answer the Smoke 100 question. Okay, so I hope that helps a little bit with this week's lab.